Okay. Okay, let's start, guys. So, hi, this is Venkat. So, I have around 11 plus years of IT experience. From the past 4 plus years onwards, I'm working as a Hadoop developer and big data architecture level. And right now, I'm working at TCS as a project lead and a solution architect level. And from the Cloudera, I'm a Hadoop developer certified. So I train more than like 1,000 plus members doing as a mostly online and so many MNC level, supporting to so many US clients and you know giving a support and getting all the big data stuff, everything. So and so I'm working as solution architect and handling all the till now we handle number of MNC clients like Cisco, Ericsson, BT, Etisalat. Recently, I went to Dubai for this XLR project. We got the project, and now working right now again working on Cisco project. So this is about my experience, guys. So what is your experience, Chitra?
Yeah. Hello.
Yeah,
Yeah.
Chitra, please.
Yeah. Hi. Yeah. I have experience around 4 years in this IT and QA, and I have experience in Python scripting and Panda libraries with Flask Web Framework.
Okay.
Yeah.
Okay,
And
good.
I have. Mhm.
Yeah.
Yeah, I have used automation frameworks, TestNG, along with Java, and also in this I have done a project in ETL project with Tectos, and it has extract the data and modify it and load it. And
Okay.
mhm.
Yeah. Great. Yeah. Thank you, Chitra.
Yeah, sure.
Shami. Shamile.
Hello. Hi, Venkat. This is Shamli. I'm the training coordinator. I actually joined because I was into 5.5 years into mainframe in Infosys. And then,
Sorry, Shamil, I can't hear anything.
okay,
Your voice is
are
too
you able to
low.
hear now?
It's very low.
Even now?
I think better I'll put the headset. Just a second.
Now? Is it fine now?
Yeah, Shamil, tell me.
Yeah. I'm the training coordinator, Venkat. Uh, I joined I'm my experience was with Infosys, but I joined here to learn also and to also clear doubts in case like if they have anything regarding the placement perspective for the trainees. Uh, and I also wanted to just get Chitra's email ID and phone number just for the purpose of the for a uh, to save it for a database. No, can you just
Sure.
ask Chitra? Can you just tell me?
Yeah, yeah, sure. I'll just type it in the chat.
Okay, yeah, I'll take it right
Uh,
away.
I just couldn't get that chat thing coming up and running. Mhm. Hmm. Anyhow, I have this. I have, it's already. Mona is the one of the organizer, and
Mona
she
has your
has my.
number?
Yeah,
Yeah,
exactly.
okay. Then,
You can get it.
then
Yeah,
okay, okay. Yeah, thanks, Venkat. I just
sure.
wanted to collect it from her, and I also wanted to. I mean, I have
Mm-hmm.
my own interest in Hadoop also, so I also wanted to know. So that's how I joined. This is Shamili, and I have 5.5 years in mainframe experience,
Mm-hmm.
and I started doing my AWS certification, and then I just got it completed. So I also wanted to have an overall, at least a knowledge of what is Hadoop and how it works and everything. So that's how I joined.
Okay. Yeah, fine.
Mm-hmm.
Yeah, I guess so. Now I'm going to start today about the basics, like what is the data, what is the big data, so why we need a Hadoop, so why
Mm-hmm.
not the other technologies. We'll see everything from the basics to advanced level. Okay. So first, let's start about the data. So what is the data? Is nothing but gathering the information, right? So how we'll store our data in terms of the bytes, right? Byte, kilobyte, megabyte, gigabyte, terabyte, petabyte, zettabyte, etabyte, and yottabyte. See, the future is about like we have a Brono byte. So if you go with the byte, kilobyte, megabyte, gigabyte, it's just normal data, right? Even our normal systems can easy to handle that. What about this? So this is a large volume, a huge volume of data. So everyone call this is as a big data, right? But this is not a big data. It's just simply a large volume. So now let's see here what is the meaning of the big data. If you know the big data, what we will think? Okay, we'll think it may be a software or a tool like that, right? But big data is not a software, it's not a tool. It's just simply a term which defines about the three factors here. So one is the velocity of the data, one is the volume of the data, and one is the variety of the data. So what is the velocity? Like the speed of the data you're getting from the source to the destination here. For example, I'm in a Hyderabad, I'm flying to the Bangalore, right? The each and every second, right? All the fly information we capture and we'll analyze the data. And then we'll say, okay, this is the height of the flight, the speed of the flight, like that. See, in a hospital, when we scan the body activities, right? We will analyze the data, we'll make a decision. So what I'm saying is here, so based on the speed of your data, right? If you got the good speed, we can easy to analyze the data. And what about the volume? In a big data, volume is nothing but this is a large volume. And what about the varieties? We have three types of the varieties here. So one is a structured data, and one is a unstructured data, and one is a semi-structured data here. So what is structure? Like the data, the format is like a tabular format, everything on a structured format. What about the unstructured? For example, see in a Facebook, we upload the videos, images, comments, everything, right? It's all the unstructured format. What about the semi-structure? So, we have XML data, JSON data, and the clickstream data we have. XML, right? It's extendable markable language. What about the JSON? It's a JavaScript object notation data. It's like an online data. So what is a clickstream? Looks like a new keyword. Suppose I'm the customer, I'm doing the online shopping with Amazon. I enter the website, I want to buy something. After they enter the site, I didn't see any offers. So what we will do? We'll just simply log out, we'll come outside, right? If you observe, right, after some time, you'll get some automatically advertisements in your browser. How you got the ads in the browser? Whatever you're doing, the mouse clicks on the website, the team will capture all of your data. They will analyze the data. They will show you some offers to you to attract the customer again. So the clicks is called as a clickstream data, and that is a semi-structured format. So like this, so we have a structure, unstructured, and semi-structure. So these all we have a different three varieties of the data. The three factors combination we call as a big data: variety, velocity, and the volume. This everything we call as a big data here. So if you see around the 4 to 5 years back, we don't have this concept, right? From past 2 to 3 years onwards, we're continuously hearing big data because the data is growing a lot continuously. As per the IDC analysis, IDC is a US based organization. So what they will do is they will analyze the data, how much we are using all the world. Till 2007, we got the zero point 0.9 zettabyte. Till 2011, we got the 1.9 zettabyte. Till 2012, we got the 2.9 zettabyte here. So if you see here, in a 4 years of the time, it just increased the 1 zettabyte. See, within a 1 year, we got the 1 zettabyte. So what I'm saying is the flow of the data is rapidly growing a lot continuously. Here, what is the main challenge is how to handle this big data. That's the main challenge we have. So here we discussed about the variety, velocity, and the volume, the three factors combination. So till now we discussed they're getting a huge volume here, and then different types of varieties here, and the velocity we have a speed. That's called the three V's in a big data. So we have one more V is also called about the veracity. It means is the data is really useful or not. I got the data, but as per the client requirement, it is the best or not. That is called about the veracity. So let's see from which sources getting the vast amount. Social media, right? It is one of the biggest example of big data getting the vast amount from different sources like Facebook, Twitter, YouTube, and see scientific instruments. See NASA team every second they'll produce all the weather reports and everything. And mobile devices, we are sending around 11 millions of messages through mobiles throughout the world in 1 minute. So I've seen in olden days we have newspapers, but nowadays we got so many websites, blogs, and apps and everything. So what I'm saying is here, all of us are generating here, and all of us are consuming here. So the main challenge is like how to handle this big data. That's the main challenge here. So let's see from sources getting the vast amount. From which sources getting the vast amount? From the mainframes, client server, internet, mobile devices, social media, and a cloud computing. So from the every minute, we got 1 lakh tweets, around 7 lakh updates in a Facebook, around 11 millions of messages through mobile, around 7 lakh updates in a Google. So guys, this is we call as a big data. Here you'll get the high speed, huge volume, and number of varieties. So here, so how to handle this big data here? Is it possible? Can we control this? For example, guys, I'll say, guys, can you please stop using your Facebook and mobile? You guys gonna stop it? No, right?
No.
We don't know. We don't know, how to control this big data. So we are looking a solution to handle this big data. So here, so my job is here, right? I want to handle the big data. So what is the meaning of handle? Means I want to store this vast amount of the data, and I want to process all the varieties of the data. So this is my job in a big data. So here we are looking a solution to handle this type of data here. Okay, so first let's go with the SQL. So what is SQL? It's a structure query language. See the name defined, it can access the only structured data. And the SQL can access in terms of the bytes, kilobyte, megabyte, gigabyte only. But what is my job in the big data? I want to store the vast amount starting from terabyte. I want to process about all the varieties. So it means I have a structure, unstructured, and the semi-structure. But see, using a SQL, we can handle only structure and the two limitations only. So means using a SQL, it is not possible to handle the big data. Like a SQL, all the RDBMS systems are failed to touch the big data. Like Oracle, SAP, Teradata, DB2, everything. They have their own limitations for the storage, and they have their own limitations for the processing. But here my job is I want to store this vast amount, and I want to process all the varieties here. Okay, so let's go with the Hadoop. To handle the big data, let's go with the Hadoop. So Hadoop is a data management framework. What is the meaning of framework? So if you say my laptop is a framework, I have a keyboard, mouse, screen, everything is integrated. I can say it's a machine. Same way, Hadoop is a framework which consists of number of components doing on different jobs like storing, processing, streaming, scheduling, everything. That all the ecosystem, all these components, everything on the single framework. So we can simply say Hadoop is a software framework. Software framework we have. So now see, Hadoop is data management here. Is nothing but in a Hadoop, right? We can store any amount of the data in a Hadoop, right? We can process the any variety of the data. It doesn't matter what is your file format. It doesn't matter like what is your size or processing. So yes, Hadoop, using a Hadoop, we can store any amount and we can process any variety here. So we got it right. What is our job in the big data? I want to store the vast amount. Yes, Hadoop can store any amount. And I want to process about all the varieties. Yes, Hadoop can process any variety here. Okay. First of all, let's see what the history of the Hadoop, how they got this idea. See, Google team, right? They released a paper. So based on the paper, Mr. Dog Cutting, he got an idea with the Hadoop. With the Apache team support, he released Apache Hadoop. Apache Hadoop is a main open source, and it is the origin we have original the main origin one. Is open source means free software, right? So Apache Hadoop is a free software. I will take the Apache Hadoop, I'll customize, I can make my own flavor. I can make it as Venkat Hadoop. Same way, based on the Apache Hadoop, we got the flavors in the market or Cloudera, Hortonworks, Mapper. So in all the flavors, right? So the best flavor is about the Cloudera team, because the Cloudera team, they have taken the Apache Hadoop and they customized, they added some new components and they installed a manager and they given us a pre-configured version. Pre-configured means everything is already installed. You just simply start and play. If you have any issue, right? So we have flavors out there, they'll help you for support part. Same Hortonworks map all same like that, but compared to all the best advanced level, Cloudera is the best one we have. Okay, so now let's see the common interview question like why Hadoop is the best solution. So let's go with the SQL or Oracle or SAP HANA, Teradata, some examples. So I'll go with the Hadoop. I'll just simply say about the five characteristics. So one is the scalability, one flexibility here, one is the cost effective, fault tolerance, high performance we have. So first of all, let's see about the scalability. Scalability means in Hadoop, right? Based on the client data, we will take the number of systems. Whenever client add the more data, we'll take the more system. So it's called scalability here. Flexibility means as discussed in Hadoop, we can store any amount and you can process any variety. But see, these are all we have limitations, right? Storage we have limitations and the processing also limitations. Cost effective. So we discussed Hadoop is a free software, right? Open source. Hadoop can run with the 1 GB RAM, 20 GB hard disk also. Okay, using Hadoop, it can run with 1 GB RAM also. It just requires the minimum cheapest hardware configurations. But if you see these are all, it's so costly to maintain the hardware and it's so costly to maintain the software also. Fault tolerance. For example, I have one file, I'm loading into system. If system crash, we lost the whole file. But see in Hadoop, when you load your file to the one system, that file will go copy automatically to second system and third system we have. Because in Hadoop, So we have a 3 times replications are available. We have 3 times replications are recommended. So based on the client's requirement, we can increase also. Now sometimes the client will say, okay, this is an important file, let's make it 5 years. That we can change it. High performance. Suppose I am running my job in the one system. If system got failure, my job will not stop here. My job will jump automatically to second system to process. So these are all the 5 characteristics here. We can say Hadoop is the best to handle the big data. Okay. Okay. So now you got the idea about the Hadoop, right? But where they use Hadoop? So guys, you know about the OLTP and OLAP, right? So what is the OLTP? It is an online transaction process. What is the OLAP? It is an online analytical process. Okay. For example, let's see. So suppose a bank application. So we have a number of customers here doing all the banking transactions. So backend we have a databases, right? So the data will automatically connect to these warehouses. So front end we have a number of customers here doing all the banking transactions, and backend everything is loading into the databases. This is called OLTP, right? It is an online transaction process. You know, these databases like a normal databases which can maintain a few months statements, like 3 months, 6 months, max 1 year. So what the banks they will do after that? So all the banks they'll upload everything into the back in a big warehouse. You know, this is a big warehouse. So here what we'll do? We will store the big data and we'll process. So he will do the OLAP, right? Online analytical process. So here my question is, what about the Hadoop? So Hadoop is a OLAP. So means using a Hadoop, we are not doing we're not doing a transactional processing. We're doing with analytics. So using a Hadoop, we can process the OLTP data or OLAP data, you know, back in big warehouse. So in Hadoop, what we can do is we can store the big data. We can store the big data and we can process the big data and we can do the analytics on the big data we have. So Hadoop is a framework which consists of number of components doing on different jobs like a storage, process, analytics, everything, right? And this is called the OLAP. So Hadoop will process the OLAP data, online analytical process. Okay, let's start the framework. So as discussed, Hadoop is a framework. We have a number of components are available here. So let's see, basically we have two of the core components. One is the HDFS and one is the MapReduce. One is the HDFS and one is a MapReduce. So these two are the core components here. From the client, we got the raw data. What we are doing with the Hadoop, we are doing the storing and processing analytics, right? So whatever the raw data we got in Hadoop, first will storage, right? The storage will take care by HDFS. And after that, the client will give some requirements, right? That will process the requirements in the MapReduce. Okay, so like this. So what is the HDFS? It is a Hadoop distributed file system. It is a Hadoop distributed file system we have. For example, from the client, we got the 100 GB data, so we will take the number of systems. Because in Hadoop, we are doing a parallel processing. So in HDFS is a distributed file system, so we are doing a parallel processing. See in a Hadoop, right? In HDFS, so each system we call as a data node. But if you take my laptop is a one data node. If you see in my laptop, I have a C, D, E or the hard disk partitions, right? Same way in every data node, logically, internally, so we have a number of blocks available here. So here we have a number of blocks available here. So what is the Oracle block size, guys? Any idea? Oracle block size 4 KB. So if you take the 100 MB file, how many blocks required? It requires 25,000 blocks. Why? Because in Oracle, the block size in a KB. Here we are taking a small file, but we need the more blocks in Oracle. But coming to the big data, see in a Hadoop, in HDFS, so we have 64 MB. 64 MB is a minimum default block size. So if you take the 100 MB file, we just require the max 2 blocks here. Max 2 blocks here. So what I'm saying is in a Hadoop, in HDFS, the block size are very high here because we're handling the big data. So here 64 MB is a minimum default block size. 128 MB is a maximum block is a recommended block size. And 512 MB is a maximum block size. So this is a question in certification. Sometimes in certification they'll ask you about the block sizes. So like this depends upon the customer data size. We will take these block size and we'll process. So like this we have a number of blocks, all the blocks in the data nodes, all the nodes in the racks, and all the racks in the cluster level. So these are the physical machines to store the big data. Okay, so let's see how the cluster looks like. So this is a cluster and these are all the racks we have, and we'll see here all the data nodes. Logically, internally we have a number of blocks. So these are all the physical machines to store the big data. So how will process? The processing will take care by MapReduce, right?
Yes.
So the processing will take care by MapReduce. So how will process the MapReduce? For example, if you take my laptop will know only binary code. But what we are doing from front end, we are writing the so different keys and functions converting, right? Same way, Hadoop will know only MapReduce. But how will submit the job from front end? For example, Java. Let's write the coding part in a Java. Everything is going to MapReduce and a processing in a Hadoop system. Suppose I don't know Java, then how will process? Let's go with the Hive. Hive is a warehouse and they have their own language called Hive query language. It's same like SQL. So you just write the query, that's it. The query is going to the MapReduce in a processing in Hadoop. So I don't know Java, I don't know about the Hive also. Then we can go for the pick. Pick is a scripting language. You just write the coding. The coding is going to MapReduce in a processing in a Hadoop. Okay. Suppose here, so like Java, Hive, and a Pig, the three ways of processing our job. The small requirement in the Java will take a 3 to 4 hours time minimum. because to write the coding is a manual, compilation manual, and submission is a manual. The same job you can do in a Hive, just take the max half an hour. Same job in a peak, you just take the max 50 minutes time. Because the coding part is less in Hive in a peak compared to Java here. Okay, so in real time, we will not use the Java for any client requirement. Only the Hive and Epic are very important. We will not use Java for any client requirement. Remember this. So I'll cover everything, but you need to be more focused on the Hive and Epic and all advanced level. And next ecosystem service is called about the scope. Scope is like a ETL tool, like extract, transform, and loading. So we will import the data from any database to Hadoop, and from the Hadoop we can export to the any other databases here. Import data from the any database to Hadoop, and then we can export also. This is called scoop. You can take care of ETL process. So these are all the core components here. Any project, right? These all here important, like Hive and Peak and Scoop, like that. Coming to the advanced components here. So we have Impala, Flume, Solar, Hue, Uzi, HEBase, Zookeeper, and Yarn. What is the Impala? Impala is from the Cloudera flavor. Impala is from the Cloudera flavor. It's like a minimum of 20 times and maximum 100 times. It's a faster for process retrieval. And what about the Flume? Flume is for the streaming the web data. Whatever you're streaming, we can store everything into Solar. And this is a part of HDFS storage. And once you stream web data, once you store, we'll do analytics here. So I'll show you the analytics called social media analytics. I'll cover this real-time project. So, and I'll explain you everything and you can do your hands-on. So till now we covered so many components. All these components are working on Linux OS. Hadoop is working on Linux OS, including all the ecosystem services. But Linux means all the commands, right? Suppose I don't know commands, then how we can play? We can go with the Hue. Hue is a web UI. It is a graphical user interface. You're just using a mouse, you can easy to play. And Uzi for scheduling job. HBase is like a NoSQL language. It is for the columnar storage. Here we will do the integrations between the HDFS to the HBase, Hive to the HBase, Pig to the HBase integrations. And Zookeeper is for the cluster management tool. And next, coming to the Yarn. Yarn is like advanced of MapReduce for processing part. So from the client, guys, we got the raw data. What we are doing with Hadoop, we are doing the storage and process analytics, right? By end of the client want to see reports. If you see now Hadoop, we have everything except reporting tool, right? So Hadoop, if you see in the market, we have a number of tools available, but all will not support big data. Only a few will support. In the top one, as per the grand chart, top one in the market is called Tableau. So guys, here I'll cover the live integration here. Live integration means whatever the changes that happen in Hadoop, automatically the reports are changing on the Tableau here. This is called the live reports you will see. Okay, so this is the Tableau we have. And coming to the market, the new important ecosystems are nowadays they are looking for in the market or the Spark also. So Spark is for the real-time processing. We discussed Hadoop is OLAP, right? I can say Spark is like OLTP, but this is running on the in-memory. So that's why it's like 100 times faster for process retrieval, right? So Spark is for the real-time process. In this, we'll see a Scala code, how we can integrate, and we'll see the Spark SQL, RDDs, all everything we'll see in this. We'll see the different types of integration like HDFS to the Scala, Scala to Spark SQL. and Hive to the Spark SQL, everything will cover in this fully advanced level. So coming to the administration part, so we will cover like how we can do with single node installation, like manually, like pre-configured version, sudo mode version, and distributed mode version. Pre-configure means everything is already available, like Cloudera or Hortonworks. Sudo mode means, so like taking a plain Linux OS, and we will see the how we do installation. Distributed mode means, so we'll take a number of systems here and we'll do process. So guys, here overall what I'm saying is I'm covering the administration part, covering the development part, covering the BI tool like Tableau business intelligence tool, covering overall the Hadoop project level explanation. Overall in this, we're covering the Hadoop project level explanation here. So we are covering here number of projects here. So we will see like how we can do with the handling also. And additionally, guys, additionally, I'm covering the R also. Like I will show you the integration between the Hadoop to the R integration, because last week, so for the statistical team, we created a integration. So this is a common issue we are getting for every project. So we implemented and we got the appraisal from the client about these integrations or difficulty last time, but now we resolve these issues. How to do R integration, like how we can do the more in-depth, deep and analytics on this data. So overall and everything. See, if you see, Hadoop is a one course, Tableau one course, Spark is one course, but I'm calling everything a single course because you'll get the good expertise grip. Okay. So overall, this course it will take at least a minimum 50 hours duration, right? Minimum 50 hours duration. All right, and daily we have 1 hour session, and weekends you can plan some timings. And from the Cloudera, I'm a Hadoop developer certified. So if you're interested, I'll guide you the process, and you can write your certification also. That's optional actually, it's not mandatory. Okay, so in this, so coming to the softwares and the materials, so we will share the two types of the drive access. One is the drive access, so which we have 15 GB of materials. So in this we have, if see, SQL materials, manual installations, all the softwares folder, everything. So you can download this software. In the next meeting we will take care of installation. And another drive is about, we'll record our daily session videos. For example, if you see the sessions, I'll suppose if you see high one, you'll see the input files, video, and the commands. Just like, you know all everything organized, guys. The only thing is practical part, because Hadoop is a full of practical sessions. And so coming to the software, right, this is a VM we're going to install in your machine. Whenever you start the machine, first go to the manager and check the management services. Check the manager, and you can start or stop or restart based on the failure. See, some are good health, some are stop bad health. If you see the bad health, then you can see the restart here. So we're just using the string service here. So like this depends on the requirement, you can stop or start or restart your services. So once you're ready with the machine, right, we can start here, right, all these ecosystem, all practicals here. So this is our overall end-to-end. And next, coming to schedule part. So this is a schedule, guys. Here we have from start with the day one. So day one, introduction about stuff is stuff from the tomorrow. We're going to start with this topic. So till the, see, you'll see the HDFS, IU project assignment, pick broad assignment, Impala. See, HBase, Spark, Tableau, R, interview questions, resumes, discussion, everything we have in this. Okay. So we'll cover all the topics one by one. At the end, we will see the end-to-end projects, and then we will help you for these integrations, or if you require any further support also, we'll help you on that. Okay. So this is overall end-to-end. Okay. So any questions, guys, please ask me. Any doubts, please ask me.
Yeah.